So in this lesson, we're going to start talking about population sampling. The learning target is to know how to conduct the Quadrat method of population sampling and to be able to understand different ways to increase its accuracy. So let's say there's a guy who just moved out. Let's call him Joe. There's a guy who just bought a house out in the country, went from the town to the country. His name's Joe, and he just bought this house that he is almost as tall as. And he bought it out in the country, and this house has a nice land with it. It's got maybe 10 acres of some woods. Let's pretend those are trees out there. And let's say this is like an old growth forest. It hasn't been touched for a long time. And Joe's actually really lucky because he finds that there is some ginseng growing on this plot of land. You can see ginseng up in here. Ginseng is something that they put in energy drinks. It helps mental focus, and it has a bunch of other wide varieties. But it's mainly sought after because of these roots right here. And I believe that ginseng roots by the pound are going for about $500 a pound for wild. And so Joe finds this ginseng growing on his new land, and he realized that he could be sitting on a possible gold mine. But he has 10 acres of land, and he doesn't want to go through and walk and try to figure out how much ginseng he has growing on this entire land, but he wants to have an idea of how much money this is all worth. If he went out there and started digging up these plants, how much money would he be able to make? So he wants to have a way of understanding how many ginseng plants are on his 10 acres of property. And so he is going to try to do some population sampling of his land in order to figure this out. So the big idea behind Joe's plan is that he's going to take his 10-acre plot of land, and we're going to pretend that it's perfectly square. He's going to divide it up into sections, equal sections, more equal than what I just drew. And he's going to randomly sample some of the sections. So let's say he gives each of these a number, these smaller parts, and so on, 9, 10, 11, 12, 13, 14, 15. And the reason he's counting these and giving them numbers is so that he can figure out, he can use a random number generator, and he can define which sections is he going to sample here. And so the general rule of thumb is that you need to sample at least 10% of the area that you're trying to estimate the population of. So if he's got 20 sections here, then he's got to be able to sample at least 2 of these sections, and maybe I'd say probably even 3 of them. And so he figures out with a random number generator, maybe goes online and calculates and plugs in, I need random numbers from 1 to 20, and I need 3 of them. And so he gets out from this random number generator that he needs to sample section number 4, section number 13, and section number 20. And so he decides, well, I'm going to go and I'm going to count the population. I'm going to estimate the population in these different sections. I have 3 of them. I'm gonna do the math, and I'm gonna figure out how that relates. How many ginseng plants is there per section, and then I'm gonna multiply that by 20 to get my estimate of the total population in my area. And then I'm gonna be able to decide, is this worth it for me to go and dig up all these plants? Am I gonna make any money off of it? So the way that he is going to actually sample in these sections is with a quadrat, and this is a quadrat right here. This is a 1x1 quadrat made out of PVC pipe. So we have 1 meter on this side, and this is the standard size that we're going to be using. You can either use this with PVC pipe, or you can build this out of wood. If you wanted to, string this off on your ecosystem, you could do it that way as well. But what he's going to be doing is putting this quadrat out in random places, and the whole point of this sampling is that everything is randomized in here. So he's not just throwing this quadrat out next to the path that he's walking down, because that wouldn't be random. He's got to make sure that he's putting this in random places throughout that section that he's trying to sample the population of. And so what he would do is, anytime that there is a ginseng plant inside of this quadrat, he would count it as 1. If there was a ginseng plant outside of it, it would not count. And so he is going to be getting the number of ginseng plants inside of this quadrat for the later calculation that he's going to be doing. He's also got to come up with a way that he is going to decide whether something is in or out. And so one way that he could do this is to put a rule in where if a ginseng plant is touching the left side or the bottom side, it counts as in, and if it is touching the top part or the right part, it is out. He could also do something where, maybe if the roots are in and then it counts, or if the roots are out, then it doesn't count. And if it's right down the middle, maybe he's going to count every other one that's right down the middle of that quadrat. But he's got to have some sort of consistent rule for counting whether or not a plant is in this quadrat. And that's a really important part of making sure that he has an accurate and unbiased sample. And so the steps that this is going to take is, number one, he is going to split up the section, or the total land, right? Like he did there. He got 20 different sections of his 10 acres. And then he is going to randomly sample 10% of the sections. So Joe was going to sample 2 to 3 sections out of those 20. And once he does that, then he's going to be able to calculate the population of each section. Sorry for my bad handwriting. He's going to calculate the population of each section. And then he's going to multiply population per section by total. By the total number. So if he comes up and through his estimates he finds out, okay, I have 5 ginseng plants per section across those 3 that he sampled. Now he can say I have 20 sections, therefore I have 100 ginseng plants estimated in my land. And the equation that he's going to use is this one right here. So this N is the population estimate. So this would give him the approximate population of the plants in whatever sample he had. So if this was the little section that he was measuring, like section, I think it was 4 that he was sampling, this would give him the population in section 4. This capital A here is the study area. So let's say he was sampling section 4, right? A smaller part of his total land. The size of that section would be this study area right here. This little a is the area of the quadrat. So if he had a 1 by 1 quadrat, this would be a 1 meter squared quadrat size, the area of it. So as you can see, we have a ratio here of the study area to the quadrat size. So if you have a really big study area, it's going to be really important to have a quadrat that effectively will cover enough of that study area. And then this N right here is the number of organisms per quadrat. And so if he puts down that quadrat, counts 3, that's where that 3 is going to go right here. So that's the calculation he's going to use for the quadrat, and this is going to be in each of those little sections. Figure out the approximate population per section, and then multiply that by 20 in order to get the total population estimate of his land. So let's talk about a couple different ways that we could increase the certainty of these population estimates that we're making in this quadrat method. So we're sampling right now 3 different sections out of a 20 section plot of land. Well, one way that we could get more certain estimates of our population is we could sample more of these. Like let's say that we had a bunch of ginseng that we're growing right in here. It's a clumped distribution, which could really throw off the certainty of our estimate here. If we had a uniform distribution, we would be very happy. We'd be very likely to have a good population estimate. But if we had a bunch of ginseng that we're growing for whatever reason in section number 7, and we didn't sample that section, that amount of ginseng would be out of our population sample. And so one way that we can increase the certainty of our population estimate is we can simply sample more sections. Now, this is in a trade-off of time, because we have to actually go and sample all those sections. So it's kind of a little bit of a give and take here. We want really good certainty, but we also, the reason why we're doing a quadrat sampling is so we don't have to go and count everything in this land area. And so another way that we could increase the certainty of our measurements is, let's say that our quadrat only takes up this much of the section, and we kind of run into the same issue as we did down here with all the ginseng growing in one specific area of the quadrat. If our quadrat only takes up a small section of this number 13, then we're not getting as much of that section sampled as we could have otherwise. And so let's say someone goes out there and they throw one quadrat out in section 13 and they count and then they're done. Well, that's not a very good way of making sure that we have that section adequately sampled. And so we can increase our effectiveness by increasing the number of quadrats that we throw out in this area. Right? If I take 20 quadrat samples from this section as opposed to 2, I'm going to have a much more accurate description of that section. Right? So we can increase the number of quadrats that we take. Another way that we can do this is we could increase the size of the quadrat. And it's the same principle, as that a bigger quadrat means we have to do more counting, but a bigger quadrat also means that we cover more of that section. So if I increase my quadrat size, I'm going to hopefully get more of the organisms I'm looking for in there, and I'm going to have more of that section sampled. I could also walk through and sample the entire section. You know, if you had a group of people and you wanted to walk through there and count every little organism that came up, every little ginseng plant that was in there, then you would have a very accurate sample. So we can increase our effectiveness by sampling more sections out of our total area. We could increase our effectiveness by throwing more quadrats out in that section, and we could increase our effectiveness by having a bigger quadrat, so we're getting more of an accurate sample. So hopefully this gave you a good intro to the quadrat method, which we'll be doing in class. We'll be going through this in class, so we can get a hands-on look at what this actually is like. But you should have an idea of how to make this an effective technique before you come to class and we go through it.